Now we are going to discuss about the k-mean clustering algorithm. It is one of the most simplest algorithm which is used in unsupervised learning method to solve unknown clustering issues. Now k-mean clustering requires two following points. The first is k, which is actually the number of cluster, and second thing is training set. That means the actual set of data. Let's say the data point can be x1, x2, x3 and xn. So these two things are required for k-means clustering. Now the question arises is that we have to choose the cluster, but how should we know the optimum number of cluster which are there? Now they can be chosen with the two best possible method. The first is elbow method and second is purpose based method. Now in elbow method what happens is like that. In y-axis there is WSS, that means within sum of square. This is actually a method which is there in the sklearn library called inertia. And when we use this particular method, it actually generates us the sum of square. So that we have plotted here. And like this, a graph is actually plotted. And let's say here the number of clusters are 1, 2, 3, 4, 5, 6. Now what happens is that initially when there are certain points, then the sum of square is greater. But reaching a particular point, let's say that this is the elbow point. The difference between the square is not much. Here you can see that there is very minute difference in several cluster. So this elbow point can be considered as the final value of cluster or the number of cluster which are need to be there. So the curve is actually drawn between WSS, that is the sum of square, and the number of cluster. It is called elbow method because the curve look like an elbow, or you can say the human point arm, and thus gives us the optimum number. This can said be an optimum number of cluster which are there. Another method is purpose based method. Now what happens in this purpose based method is that we can run the k-means clustering algorithm to get different cluster based on varieties of purpose. Now you can make the partition of data on different matrices and you see how well it performs on particular cases. For example, we take the size of genes. So what happens is like that, if we say like this, and there are several clusters which are marked. These can be said as the several data points, okay. Now this is one particular cluster, this is also one particular cluster, and this is also one particular cluster. So these are three clusters. Now we can say that the gene size, it could be of small size, medium size and large size. So that determines us that for three sizes, that means the number of cluster k equals to 3. So that the prices are cheaper, you will divide the data set into the 3 clusters. Now if you want to give the variety, then what happens is the variety of purpose is the major reason for purpose based. So here you have only 3 clusters. Next, if you have like this, so these are the 4 sets of cluster. Let's say small size, medium size, large size and XL, extra large size. So these are also the varieties of clusters also, and you want to provide more comfort and variety to your customers. So for that you have to divide the data set into another varieties of cluster, and here you can see that the k is equals to 4. You can have another variety also, that is extra small excess size. So that will add 5 varieties of the genes to the customer. So this actually varies on purpose based, whereas this varies on sum of square and having an elbow point. These are the two ways of actually getting that how many cluster we need to have. Next, we are going to discuss about the algorithm of k-means clustering, that how it operates. So in the algorithm of k-means cluster, the step 1 which is there is, or we can say the step A which is there is, first we need to specify C. That means C equals to number of cluster. Randomly select C cluster as the centers. For example, you can see like this, if this is a particular X and Y axis, and here I am having several data points. So these are the clusters which I have, and here I can say that this is my one cluster centroid and this is my another cluster centroid. So this is how I have firstly initialized. The k-means clustering algorithm is an iterative algorithm, so it follows next two steps iteratively. Once you are done with the initialization, next we go for the cluster assignment. So what happens in the second step is that calculate the distance of each data point from the cluster center. That means we are calculating the distance of each data point from cluster center, or we can say as centroid. So what here we do is we calculate the distance. So let's say if we are taking this particular data point, so I will calculate the distance from this centroid also, and I'll calculate the distance from this centroid also. Similarly, we take this data point, so I'll calculate the distance from this centroid also, and I'll calculate the distance from this centroid also. That means I will calculate all the distances from this respective centroid of all the data points. In next step, what we do is, now we move the centroid. So we have taken both the centroids here. Now what we do is, these are our data points. So one centroid now I move here, another centroid now I move here. And then I calculate again the distance. So I calculate all the distances by changing the point of the centroid. Next what I do is I recalculate the new cluster center. That means I will get definitely a new value, so that I will take as new cluster center. And how can we recalculate? We calculate like this: V equals to 1 by C, let's say Ci here for first step which we did, summation of x1. Now here Ci represent the number of data points with the ith cluster which is there. V is actually to be said as the set of centers. That means how many centers you have taken that particular set of centers. Now you recalculate the distance between each data point with the new obtained. Here is the new obtained. So you calculate the new obtained centroid. So you calculate here the distance again. Lastly, if no data point was reassigned, then you can stop. Or if there is no as such value which is generated of different, such as the distance comes out to be same and approximately to be the same, then you have to stop taking any new centroid. And what you have to do next is that you have to stop the algorithm when if no data point was reassigned. Then stop, or else you have to repeat from step 3 again. You have to repeat from this step again. After assigning the centroid, you have to again move the new centroid, calculate the new cluster center, and then the distance again. And if there are no data point reassigned, then you have to stop. So these are the certain steps which are repeated in the k-means algorithm. Now we do not need to do all this, by writing any particular steps of code or such things. We can simply import the k-means from the sklearn library. It has an inbuilt k-means algorithm function over there, and we can simply use it and it will allocate by itself and then give us the new centroid. So we have to not, this is actually the basic brief I want to give you, that how this particular algorithm works. But while programming, we will directly import it from the sklearn library. So this is all about the k-means clusters algorithm and the steps of algorithm, and also the types by how can we discuss or how can we declare the two centroids, that is, it can be purpose based or it can be algo method also. Next, we are going to straight away jump to the coding portion using the k-means algorithm for unsupervised machine learning.